Hello, everyone, and welcome to our first webinar on the value of robotics for education. Today, with the help of our experts, we will explore how you can transform your classroom with robotics. Today, the robotics market is experiencing rapid growth, and robots play a pivotal role across different facets of production. We often hear about the importance of virtual factories to optimize the operation and collaboration of these robots. As a result, robot programming becomes a key discipline in education. Since robotics is a field that relies on multiple areas of study, from computer science to mechanical and industrial engineering, manufacturers have a hard time hiring the right talent to tackle the challenges that they face. You have already probably heard about the term skills gap, a misalignment between the skills possessed by the workforce and the skills demanded by the labor market, and it is tremendous in the manufacturing industry. So, as an educator, your main goal is to prepare engineering students for their future careers, empower them with emerging skills in robotics, and make them reach their full potential. However, how can you achieve this without a physical robot station? Let's see today how you can help you align these skills with the ever-evolving needs of the industry. And talking about industry, this will be our first topic on the agenda. We will try to understand the power of robotics, explore real-world applications via an industry use case with Julien THEVENON, our expert. Then we will see how you can transform your classroom with our education experience, which is our offer for educators, with Thierry CARNEIRO. And last, we will see how you can empower the workforce of the future and give you some offer details with Romain FAUCHER. Last but not least, we will have a Q&A session at the end, so feel free to ask all your questions via the Q&A function in Zoom. And then we will conclude this webinar and tell you how you can reach us if you want to learn more. So, Julien THEVENON, the floor is yours.
Thank you, Deya. And hello, everyone. So actually, not long ago, I was a student myself, and I was lucky enough to learn how to use CATIA and SOLIDWORKS at my university. When I started to study manufacturing and robotics, I was a bit surprised because we spent a lot of time doing hand calculations of things like robot kinematics, but we never used any software. And at the time, I remember asking, wondering that if I was missing out on some key, hands-on skills that are required in the industry. All right. So in robotics, you will get to work with many robot brands, from established names like Fanuc, ABB, or KUKA, but also some big emerging players, mainly from China, such as Xiaosun, Obo, Effort, or Innovance. And this diversity is a challenge because each brand uses its own unique programming language. So how can you learn to work with all these robots? Well, our customers have the same question. And that's why we at Dassault Systèmes, we developed a robotic solution which can simulate robots from any brands. In DELMIA Robotics, you can simulate and program dozens of robots from different brands within the same environment. And for that, we provide, out of the box, a large robot library of more than 2,000 models. And we regularly update this library to make sure that it includes all the latest models. In DELMIA Virtual Factory, you can design the layout of your simple robotic cell, or you can very easily design the complete layout of your factory. You start very often by a 2D layout, or you can also start just by adding 3D models, either from our library of robots or our library of equipment, or by getting 3D data from the equipment manufacturer. You can also easily design any equipment like NC machines, robots, clamping systems, conveyors, and so on, by simply adding the kinematics on top of the 3D. Another thing you can do is run discrete event simulation using your virtual twin to understand things like throughput and production bottleneck to optimize your factory. Robotics can cover a wide range of manufacturing processes, and they are all covered by DELMIA. So it starts with material handling, also known as pick and place. A good example is machine tending, and Thierry will present this use case in a lot more detail in a minute. Another important category is point-to-point processes, like body and white that we are seeing here. Body and white is spot welding for car or truck body. And here we are seeing a typical line composed of many robots and weld guns. And for this process, we have to ensure that the robot doesn't clash with the car body, but also doesn't clash with the tooling. So you can see the product being on the rail. And also we have to make sure that the robot don't clash between them. In the point-to-point process, we also cover a very important process for aerospace, which is called drilling and rifting. But we also cover things like studs and bolt welding. Another important category is surface processes. So in surface processes, we cover things like painting, shot pinning, and polishing. Here we are seeing the painting process of a car. It's a very interesting use case because we are seeing a rail tracking and line tracking working at the same time. And what's interesting to note is that the robot trajectory is defined from the geometry of the product. And in this type of use case, we can go as far as simulating the painting thickness on each area of the car, or things like material removal, for example. Then we cover also contour or curve processes. So with things like arc welding, sealant deposition, or roller reaming. Here we are seeing a typical arc welding cell where we program the robot synchronized with the positioner at the same time. And finally, we can also combine the strengths of our DELMIA machining solution with DELMIA robotics to do things like milling operation. So here we're seeing deburring. We can do also drilling. We can do engraving, many different types of processes. And we can also do processes like 3D printing with our DELMIA additive machining. And by having one solution for all your robots and all your processes, it becomes much easier to maintain skills and create best practices. Another strength, of course, is that our solution is well connected with CATIA and SOLIDWORKS. So our customers can, for example, design their product in CATIA and their tooling in SOLIDWORKS, then define their process in process engineering before doing their robotic simulation and offline programming in DELMIA Robotics. But by doing this, it makes the entire process fast and efficient, and it also speeds up new product introduction and change management. You can also upload an existing program from the physical robot into DELMIA Robotics. And once the simulation is complete, you can easily download your program to the physical robot in the shop. Another strength of our solution is that we can easily connect with the physical world. So what do I mean by this? Here we are seeing an example of DELMIA Robotics connected with the VRC, or Virtual Robot Controller. In the video, we are showing the capacity to easily connect with FANUC RoboGuide. And by doing this, we can get the exact cycle time of the robot and save time for the final TP FANUC programming. And another way we can connect with the shop floor is with virtual commissioning. We can connect with the physical PLC or the emulated PLC to test the program that will control the entire cell. We can do all this testing for a simple work cell or for a complete line virtually before the commissioning of the line. So let's now see some real-world applications with a couple of industry use cases. Actually, I forgot to say, but our solution is #1 in aerospace. and our biggest customers are big car and truck OEMs. And most of these large companies, they outsource their robotic integration to tier 1 line builders. So in this case, I thought it could be interesting to hear the experience of one of these smaller companies. So the first one is a company called CIS Optimax. It's a robotic integrator working with Renault, so car OEM, in DELMIA Robotics 3D experience. Let's listen to what they have to say.
Nous avons deux défis principaux. C'est premièrement répondre aux problématiques clients, donc apporter des solutions techniques innovantes, de respecter les coûts et les délais. La plateforme d'Asso System nous a permis d'avoir un système très collaboratif entre nous, fournisseurs de solutions techniques, et le groupe Renault. Après cette première expérience réussie, nous avons d'autres projets dans l'automobile et nous souhaitons aussi développer cette activité 3D expérience dans le secteur aéronautique.
Nous réalisons les trajectoires de manutention, de dégagement et d'approche, et nous réalisons également les simulations des cordons de soudure. Grâce à cette solution, nous sommes en mesure de montrer clairement à notre client la faisabilité technique qu'il nous demande. L'intégration de DELMIA Robotics avec SOLIDWORKS nous a permis de pouvoir faire des modifications instantanément en quelques clics. Oui, donc un exemple concret, le produit du client a évolué. En quelques clics, nous avons pu faire la mise à jour sur DELMIA et simuler et valider nos modifications. Nous avons été accompagnés par SIMPA, partenaire d'Asso System. Aujourd'hui, j'ai une parfaite maîtrise du logiciel 3D Experience. Et au besoin, Asso System a mis en place un support sur Internet qui est nommé EDU Space, où est-ce qu'on peut retrouver différentes formations. Dans les fonctionnalités que j'ai bien aimées, c'est celle pour créer les cordons de soudure. On peut également faire apparaître la torche de tour. On va pouvoir régler un point en particulier, modifier un angle, et on voit en dynamique l'encombrement que la torche peut prendre par rapport à l'outil. On peut également ajouter une option qui permet de maintenir le robot en position pour pouvoir regarder un peu plus précisément où est la collision. Un autre point fort de DELMIA, c'est la mise en place de bibliothèques de robots avec leur contrôleur intégré sans surcoût, ce qui permet de choisir n'importe quel robot de n'importe quelle marque et de pouvoir en sortir le programme robot associé. Un autre point très positif, c'est que la solution est 100% cloud. Cette solution est facile à installer et elle permet d'avoir toujours la dernière version.
Donc la force numéro 1 aujourd'hui de CIS Optimax, c'est l'innovation d'Asso System et notamment le jumeau numérique pour me permettre d'étendre demain mes propositions de valeur auprès de mes clients.
We can see how the cloud makes the deployment of our solution super easy, right? I have another example for you today. Company is called Prodomax. It's a large line builder based in Canada, and they are using our solution mainly because of its collaboration capabilities. Indeed, with the 3D experience, there is no file exchange anymore, and it's very easy to have several users to collaborate on the same data sets.
Now that Julien showed us a bit the capabilities of the 3D Experience platform around manufacturing and robotics, I'll be showing you what we are currently working on and delivering around the academic world. But before, let's start by highlighting the different challenges that you, as educators, are facing today during your activities. So I think the biggest challenge that you are facing as educators in the academic world is to prepare your students for future employability. You need them to acquire the right skill in order to boost their employability and then to be ready for their future job in the industry. Another challenge that you are facing is that you need to develop, of course, comprehensive curricula for your students, and this with a lot of constraints. And one of the main challenge you have with these constraints is the time. You need time in order to ramp up on solution to build the right materials for your students. Similar to this, you need also to have access to materials, to data set that you can reuse in your project for your students in order to allow them to understand how to work for their future job. And lastly, one other challenge is that you need sometimes for some of you to build virtual hands-on activities, because we know for some of you, you don't have necessarily the budget, for example, to build the real machine, the real robots on the workshop of the schools. And so you will need to create hands-on activities to have other solutions in order to teach your students how to work for the future. You have, I'm sure, a lot of other challenges in your activities, but this is to understand and answer all the challenges that we have created in the SO system and in the Experience EDU department, a new approach that we call the education experience. And for our case of robotics and virtual factory, we call it the virtual factory education experience. So what is this education experience that we will provide to you? This education experience will be an end-to-end teaching scenario with ready-to-use datasets that you will be able to take on your environment to perform your classes. So here on the middle of the screen, you can see a 3D data that we have developed in collaboration with experts such as Julien in order to insert all the different tools, features, and disciplines that you need to understand in order to build a virtual twin of a factory. And so the objective is to create all the different assets in order to you to ramp up on this solution. So how it will look like? We will have a learning path for this education experience that is respecting your time constraints, and that is based on our 3DS skill referential in order to ensure that the students are getting the right skills for the future. And we will be delivering for you, to you educators, learning module that you can see on the screen on the different disciplines in order to first start using the platform and adopt our solution. So you will have different learning modules on the different disciplines, such as process engineering. If you want to create the MBOM, create the process plan of your data, layout and flow simulation engineering, machining, additive manufacturing, robotics, ergonomics. So all these disciplines that will allow you in a single data set to understand how to break the silos and how to improve the collaboration between the different people in a manufacturer. All this learning path is, of course, certifying. So your students at the end will be able to have digital badge to post on social media in order to boost their employability. And when you will be having done all this learning paths, we will also provide you, and it is already available on our learning platform, 3D Experience EDU Space, you will have access to a library of advanced content. And for example, here for robotics, and you have seen Julien told us a lot of capabilities around painting, spot welding. So all these advanced contents are already available on 3D Experience EDU Space. So you can go there, ramp up on this solution, and get certified with your students. So now let's do a focus on the topic of today, that is the robotics learning module. So here I'm going to show you a quick demo of the learning module. So this is what we have developed for you. Please wait a little bit before scanning the QR code. I'll tell you when you will be able to scan it in order to have all the information. So let's start the quick demo. I will be doing a live demo with you. So as you can see, we are in the final dataset of the virtual factory education experience. And here you can see, this is the final result. This is what you will be able to learn and to do on your platform. And the objective is to program the two robots you can see on the screen for doing a pick and place activity, material handling, as Julien explained before. And so you have to program the robot on the left that is picking the raw material and putting it on the NC machine. And here, the robot on the right will be taking the final loss part and putting it out the box on the conveyor for the next process. So the objective of this learning module is to create this whole robot program. And you will start with the beginning, meaning that you will start by importing the 2D layout, and then you will have to build step by step all the different process to have the robot program done. So you will start by importing the catalog of resources, inserting them in the 2D layout here as the machine, and then you will learn to use the different features such as the snap command in order to snap resources to the 2D layout, and also attach resources together by creating different ports. As we can see here, you will be creating the ports, for example, between the support and the robot in order to attach them. So you will be able, after, when moving the table or the robot, that both resources will move along together. So you will learn to create all the 2D layout, and once it will be ready, you will be able to move to the next step, which is the kinematics. So as you have seen, the objective is to create the pick and place activity. So you will need a device on the robot that is able to take the part, put it on the machine, etc. So you will have to create the kinematics for the gripper, which is the tool that will allow you to do the handling activity. And so you will create the different joints to be able to manage the pick and place activity on the robot. You will also be able to manage the different device attributes, such as home position, speed and limit acceleration, and other. And you will be able to manage everything from the same command. Then, once the kinematics is done, you will be able to create the ports to attach the gripper on the robot, and you will be also able to create the other ports, such as the TCP, the tool center point, to help you for the robot program after. So we have the 2D layouts, we have the gripper, we can attach them, the robot and the gripper together to continue to create the trajectory. So here, we'll be attaching them in the same motion group. So you will be able to manage the whole robot motions plus the gripper at the same place. And you will also be able to add some robot profiles in order to put the characteristics that you need, such as object profile, tool profile, the accuracy profile of your robot, in order to perform then the real simulation. So when your robot is ready, the next step will be to create the different points that we call tag points, that are the different coordinates that the robot will need to reach in order to perform the different activities. So here you can see we will put some points on the raw material that needs to be taken, and we will define all the different points, all the trajectory, finally, that the robot will need to reach in order to do the pick and place activity. We will also use what we call simulation states in order to help you to create all these different points. When the points are ready, we need to do some quick analysis to ensure that the robot can reach all these points and that to ensure that the robot is correctly positioned. And here you can see on the green, meaning that the robot is correctly positioned on the layout. Now that we have everything working well, we are able to generate the robot task with the robot trajectory with all these points. So here the objective will be for you to create all the motions of the robot point by point and activities such as the pick and place in order to create your robot program. So here we are doing the trajectory for taking the raw material that will be on the NC machine, and we are creating the different points to define the right trajectory. We will then be creating the grab and release activity. So here it is the grab activity. And then we are able to move it to the next tag in order to do the right trajectory. Once all of this is ready, you are able to do some simulation, ensure that there is no collision during all the travel time of the robot. And if there is, you will be able to change and correct the trajectory. So here you have created the movement of the robot. You have created the robot, what you call the robot task. And now you will create IOs, so input and outputs, that are parameters that allow the robot task to communicate with each other. The objective here is to create not only the task, but also to ensure that they are all played in the right sequence with the right instruction and the right logic. So you will be able to connect all the tasks together in order to perform one final simulation of the whole system. And here we can see that we are going to create a parallelism instruction in order to play the two tasks of the two robots at the same time. And at the end, we will be able to play the final simulation that we have seen at the beginning, and you will have completed the learning module by creating everything from the 2D layout until the creation of the trajectory and robot simulation. But actually, this is not the end, because now you have successfully created it on the 3D experience platform. But if you have the real robot on the workshop, you will be also able to create the robot program, meaning that you will be able to import the right translator on the platform in order to translate the robot program on the 3D experience platform to the right native language of the robot. So here we have 2 robots from the Universal brand. And so using the platform, you will be able to, as you can see, translate the program on the right language. So now you can scan the QR code, and this is what you will have access to. So this is the whole module that I have explained to you with all the different lessons, explaining all the topics that we have seen together in these 6 minutes. And inside, you will have all what you need. Even if you are a beginner, you will have all what you need in order to perform the module on your environment, meaning that you will have all the terminologies, the concepts, the definitions that can be on the vocabulary for the expert vocabulary or for the theory in general, knowing how a robot is working, etc. You will have here, for example, some definition about the device attributes. And then you will have some activities with the datasets that you can import on your platform and all the step-by-step activities with also some practice if you want to practice on your side with your students. We will have other knowledge check and other links if you want to go further in order to learn more about specific topic. So we have this for all the different lessons. So you can go there, you can scan the QR code to have access to all this data. And by the way, if you are already using the platform and you have the 3D experience engineer role or the production engineer role, you will be able to replay this learning module. So replay this module and please share us your feedbacks. This is very critical for us because this module has been designed and developed for you. So we need to have all your feedbacks, knowing if what we are doing is helping you in your teaching activities. And by having all your different comments, we will be able to improve the development of the future learning modules, because as you have seen, we are delivering a lot of learning modules. Some are coming soon on machining, on layout and flow simulation. So it will greatly help us if you can share with us some of your feedbacks. Also, stay tuned with us. Today we have 2 communities that are really important, I think, for you and will be very useful. The first one on the left, the 3D Experience EDU Academics. So this community is for teachers. So if you only need to have a 3D Experience ID to connect and to be a teacher. And inside this community, we are sharing with you all the different information we have around the education experience. Whenever we will be delivering new learning modules, you will have the information there. We will put some videos, best practice. So stay tuned in this community. And we have also another community more on the robotics side, managed by the expert of the Dassault system on robotics. And here also, so this community is public. Anyone can access to, and you have DS colleagues, you have people from the industries also sharing content. So it is also, I think, a good place to find information around this topic. And finally, if you need any other information, more information on the education experience and on what we are building here in 3D Experience EDU, go to the website. We have this website built for the Virtual Factory education experience, where you will understand why we are doing this, how we are doing this. You will find also videos, white paper, the replay of this webinar, and you will also be able to contact us if you are still not a client and you want to have more information.
Yes, but to empower your student for having the best job in the future, first you need to access to the tools. Let me introduce the 3D Experience platform and the offer details. In order to perform a virtual factory, you need first, if you are an existing 3D Experience customer, to add one role called production engineer, or if you can also access to, I would say, 100% of the content now, because Thierry did a great job about that. If you own the 3D Experience engineer role, it is this one. It is more for the SolidWorks users. If you are a new customer, you need to acquire two roles. The first one is the foundation of the platform in order to access to all the collaborative tools. This is what we call collaborative business and industry collaborator roles, plus the production engineer or 3D experience engineer roles, if you are a SolidWorks customer. Just in order to demystify the 3D experience platform, to add these capabilities to your existing solution, 3D experience platform, it costs approximately starting from €7 per student and per year. And you will be able to perform all the digital factory courses that Julien and Thierry introduce before my part. What is included? All the on-cloud, means SaaS software environment. This is not necessary to deploy a complex solution. You will access to all the education experiences, not only for the virtual factory, but we will launch in a couple of weeks additional education experiences, and stay tuned. You will be invited also to have different others education experience in order to teach SysML language by using system engineer or design capabilities, or ModSim, adding simulation to your design. You will also access to all the official communities for you, and one dedicated for your student, because if they want to have some support on feature on the platform, we have one community is dedicated to them. But also, we will launch soon, in a couple of weeks, new apps called the teacher apps, in order to administrate easily your classroom. The value of a 3D experience platform at different level. The first one, it is at the school level, at the university. You understood with the Julien introduction that it is the 3D experience platform. It is a professional grade solution, and it will ensure the best employability for your student. I would say a lot of big companies, large companies, using the 3D experience right now in order to design their product, but also to manufacture their solution. This is really important. This is a fully secure and up-to-date SaaS solution. If you are fair about the pirate and others attacks, be sure we are fully secure, and what you are doing on the platform will be protected by our services. You understood it is a multidisciplinary and collaborative solution. Means by using the 3D experience platform on the university level, you will be able to add some capabilities in the future just by adding roles. And we also provide the certification capabilities in order to certify your student to empower their employability in the future. This is exactly the same certification that the professionals are using on their companies. For you teachers, for sure, providing the solution, it is not enough. Providing the lesson, it is not enough. That's why we decided to change a little bit the rules, and by providing to you the 3D experience, education experience, sorry, you will be able to get all the content, all the assets in order to perform your own lesson. For sure, you can use what we have in the EDU space in order to perform your courses, but you will get all you need in order to create your own lesson. This is really easy to use, easy to deploy. This is a cloud and SaaS environment. It is not necessary to build a complex infrastructure. It is just accessible by using an ID and a password. And you have a dedicated support team in order to answer to all your questions all the time, accessible through the communities, but also by using the support apps on the platform. Now for the student, for sure, student will be trained on a professional best-in-class solution used by the big companies in the world, but they can also access to an home use license for free. If the university schools is using the platform, by giving an access to the platform, the student can also develop their own project by using what the university is giving to them. This is a fully collaborative and secure environment. This is really important if you want to work on a large project with a different discipline, or by also adding some other schools to your project. This is really easy to do, easy to collaborate. And at the end, for sure, for the student, having a professional certification, this is the best thing that we can have in order to ensure the best employability for the future. All those things are accessible just by using the 3D Experience platform. It is a role to add or a platform to set up for you by using the right discipline on the schools. It costs a couple of dollars, a couple of euros per student per year. Don't hesitate to come back to your partner, 3D Experience partner, Dassault System partner, in order to have more information about the 3D Experience platform, and don't hesitate to reach us.
I think we've reached the end of the webinar. If you're interested in what you have seen today, please contact your reseller or one of our speakers below. So I leave the contact information on the screen. Thank you all for joining. I hope you have enjoyed this webinar, and also feel free to learn more on our website, 3ds.com/edu. Thank you.